Hello and welcome to today's GFG problem. So let's see what the problem says. So the problem is trying to tell us is given an array, a sorted array, right? And the sorted array contains zeros and ones. So when it is sorted, so definitely zero will start and then followed by one, right? And then there will be ones, right? So what the problem is trying to say is whenever we encounter the first one, return the index of that. Return the index of that. So what in this case, what will be the index of the first one? 0, 1, 2, 3. So you have to return 3. Okay, so I hope you got you must have got the problem. Now let's see what are the two approaches. So first, let's see what will be the naive approach, right? What will be the naive approach? So here that and another thing is the time complexity, expected time complexity is O of log n. Okay, so let's see what is the naive approach first. So the simple solution can be just to iterate, just to have a for loop, a single for loop. Okay, and whenever we encounter one, just return the index, right? For int I equal to 0 to n, right? If arr of I equal to 1 equal to 1, then return I, or else return minus 1 if we don't have any 1, right? If we don't have any 1, but the time complexity will be in this case will be O of n, right? As we are iterating the complete array. Okay, so the expected time complexity is O of log n. So when it is O of log n and as the array is sorted, right? So what comes into mind? So definitely binary search comes into mind, right? Binary search. So this problem is also an application of binary search. So what we'll do, what the idea will be? Let's quickly see. So what we'll do is, right? If this is the example, so what we'll do, we'll have two pointers L and R here, right? So whenever the mid, let's take an example. Let's take this example, right? 0, 0, 0, 1, and 1, right? This is L, this is R, right? This is R, right? So what will in the binary search, what we do generally? So we calculate the mid, right? L plus R. So what will be L 0, 0, 1, 2, 3, 4, and 5. So L will be 0 and 5 will be R. So what will we calculate mid, right? Mid equal to L plus R by 2, right? So in the case 5 by 2, it will be 2. So what will be the mid here? 0, 1, 2. So mid will be here. Now the idea is whenever we encounter in the mid, right? Whenever we encounter 0, that means right, we want to find the first one. That means the one is greater than mid. The one is present after the mid. So simply what we'll do if we encounter 0, then we will simply increase our left pointer, mid plus 1, right? In search of 1. Okay. And let's say whenever we encounter 1 in the mid, right? 1 in the mid. For example, let's say our mid comes here, right? Our mid comes here. So this is not the first one, right? So this is not the first one. We don't know whether it is first one or not, right? We don't know whether it is first one or not. So what we'll simply do is we will decrease our right pointer, mid minus 1, in search of the first one, So R will be here, L will be here. Then we will calculate the mid again and we'll see whether it is giving us whatever, right? We have to do it till L is greater than R. I'll show you. I'll quickly walk through the. So in this case, right, L, R, the mid will be here. The mid will be here. So again, what we'll do? L equal to mid plus 1. So we'll come here. L and R will be same. 2 plus 2, right? By 2 equal to 1. So sorry, equal to 2. So here we'll get. So quickly, let's take one example quickly. Okay. What we'll do? 0, 0, 1. Let's take this example and also write the code, right? For example, int L equal to 0, int R equal to 0, right? While how to implement the binary search? We have to continue till L is less than or equal to R. So what we'll do, we'll calculate the mid L plus R by 2, right? L plus R by 2, right? And what will the solution R of mid, if it is 0, right? If it is 0, then simply what we'll do, L equal to mid plus 1. That means the 1 is after this mid. That is why we have to increment the L, right? That is why we have to increment the L, right? And if else, if it is 1, right? Either 0 or 1. If it is 1, then simply what we'll do, we don't know whether it is first one or not. So we'll simply what we'll do, we'll go in the left to find the first one in search of first one. So R equal to mid minus 1. So let's quickly take an example here. 1, right? So let's calculate the mid here. 0, 1, 2, 3, 4, 5, 6. So 0 plus 6, right? 6 is R by 2. So what will get 3, right? So 0, 1, 2, 3, right? 0, 1, 2, 3. So our mid will be here. Now, this is 1, right? But we don't know whether it is first one or not. It may or may not be. But still, we have to go in search of first one to the left. So what we'll do? R equal to mid minus 1, right? R equal to mid minus 1. right? So R will be here now, right? So 0, 1, 2. Again, 0 plus 2 by 2, it will give you 1. So R mid will be here, right? Mid, right? So again, it is 0. So what we'll do, we'll go to the right to find the first one. So L equal to mid plus 1 will happen, right? Mid plus 1. So what our L will point over here. So 2 plus 2, right? Now mid equal to 2 plus 2. 2 plus 2 by 2 equal to 4 by 2, which will give us 2. So our mid will be here only. Our mid will be here only, right? Now mid again is what? 1. But this is the first one, but still we don't know. So it is first one or what, right? So what we'll do, we'll go left again. So what we'll do, R equal to mid minus 1. R equal to mid minus 1, right? R equal to mid minus 1. So our L will be here, right? And R will be here. Now this condition will break now because L is greater than R. So simply what we'll do, post the while loop, right? We'll simply return L. Always L, right? Whenever the condition is broken, this L index will return the correct first position of the 1. So this is the solution. I hope you must have got. Let's quickly okay. So here I have already implemented, right? So here see L equal to 0, R equal to n minus 1, right? Now this check is if for this one, for this example, right? 0, if we have all the zeros, right? And no one. So we are checking whether the last limit is 0 or not. If it is 0, definitely there are no one. So we'll simply return minus 1. Then as I said, right, while L is less than equal to R, mid equal to n plus R by 2, right? And if we get 1, will move to the left because we don't know whether this is first one or not. We'll still go to the left. And then if it is 0, we'll move to the right in search of the first one, right? And simply whenever the condition breaks, when the while loop finishes, the L will always be pointing to the first one. Okay. So this is the problem and the solution. Let's submit. Yes, it is accepted. Okay. Thanks for watching. Kindly like the video and subscribe to my channel. Thank you.